That's the sound we like to hear. That makes sure that when we upload it to YouTube, it'll be the entire thing. I'm gonna check our time here. No, not.
Thank you.
Right at noon. All right. Hello, everyone. Thank you for coming out to our final random review of the 24-25 season. My name is Brittany. I am a community library specialist here at Corvallis-Benton County Public Library. Thank you all. I think I've thanked you a few times now already, but it's starting to turn into a lovely day out there. So thank you for being here. I do have some thanks to give out and folks to acknowledge before we get rocking. So I'll start with the random review committee. As I mentioned last time, which I do apologize if there was some confusion. We did have to switch reviews. Last month was the Covenant of Water, and this month is fire weather. That is what you're here to hear about today. If you missed the Covenant of Water, that video should be up on YouTube soon, and you'll be able to watch it there. So thanks to the Random Review Committee. They meet once a year to pick the 10 titles that we'll talk about. We've already met. I talked a little bit about it last time, but it was a very fun and relatively debate-free session, so that was good. Thank you to Gary Whitehouse for writing our wonderful press releases. And thank you to the Friends and Foundation of the Library for their co-sponsorship and support of Random Review. If you don't know, the Friends not only founded and ran the Random Review series for 30 years, they also coordinate and run the book sales whose funds benefit the library and support us in so many ways. Let's see. You can go to our webpage and find the Random Review webpage, and that's where all the scheduled events, all the YouTube links from this last year and previous years, so you can go back and watch and listen to all kinds of things. There's also book lists on that website, which are compiled by our volunteer, Gail Gerdeman. So thank you, Gail. And I think that looks good. So I will not stop talking, but I'll stop talking about us and start talking about Matt Reilly. Matt is a forest ecologist and grew up in rural Massachusetts, exploring the coastline and forests of New England. He received a BS in Natural Resources from the University of Vermont in 1999 and an MS in Forest Resources from the University of Georgia in 2004. Prior to moving to Corvallis in 2010, Matt spent 10 years working in the southeastern United States as a botanist on fire-related research. He received a PhD in forest science from OSU in 2015 and spent 2 years as a postdoc at Humboldt State University. Matt's current work integrates field data with remote sensing applications to study vegetation response to disturbance, particularly fire, and climate change. He lives outside Corvallis with his wife and 2-year-old son. So please join me and welcome Matt.
Hey, thank you. Up higher. Thanks so much for coming out. I'm excited here. I give a lot of presentations, but they are very rarely, if ever, I guess never, sort of a book review like this. And it's interesting because science is my profession. I sort of eat and breathe it all day long, and I rarely read things like fire weather that are science-based and things like that. These days I do a lot of reading of kids' books and things like that, and a lot of emails and a lot of scientific literature. So it was really enjoyable to dig back in and take this on. And I currently work as an assistant research professor at Oregon State University with the College of Forestry. And I'm going to tell you a little bit about myself as we go on. But I'm going to start with just sort of a roadmap about what we're going to talk about today and where we're going to go. And I'm going to give you a little bit more of an introduction about myself so you can sort of get to know me and the work that I do and the places I've lived. We're going to do a brief lecture on fire ecology 101. And the goal of this is really to introduce you to some terms and things like that I'll probably use and give you a little bit of scientific understanding for a bit of the basis of the book. And then we're going to talk about parallels with the 2020 Labor Day fires. And so who was here for that? Yeah. I mean, this was when I saw this book come up and this opportunity, it was initially like, oh man, am I going to do a book report or something like that? And it's not that at all. And so it's a really interesting opportunity, I guess, to sort of look at parallels between this event up in northern Canada and one that hit really, really close to home here in Oregon in the recent past. And then finally, we're going to just talk a little bit about sort of living with wildfires and how, we as people might be able to adapt and things like that. And so whenever I give lectures to undergraduate classes,
I like that picture better.
okay, we'll skip that. I currently live, okay, we're back. So just to, I grew up in Massachusetts and spent a lot of time in New England. And then during college, I went down to the southeastern United States, and ended up there for quite a while. And that's really where I got into fire ecology. I worked a lot in longleaf pine ecosystems in the southeastern coastal plain, and also up in the mountains in the southern Appalachians, looking at wildfire effects and things like that. And it was also during this time that I sort of got exposed to landscape ecology. And landscape ecology is a discipline of ecology that's really interested in larger scale patterns that manifest themselves across landscapes. And so I used a lot of GIS and remote sensing and things like that. And then I moved out here in 2010 to start a PhD at Oregon State University. And this is where I sort of shifted from that botany focus to more of a landscape ecology and regional forest dynamics. And so looking at things like the effects of wildfires and other disturbances at really, really broad spatial scales to try and get an idea of the magnitude of their effects and how quickly things are changing. I spent a couple of years down at Humboldt, dove back into the botany, spent a lot of time in the field down in the Klamath Mountains looking at fire effects and things like that. And then came back here right before COVID in 2020. And I was working for the Pacific Northwest Research Station at the time with the Forest Service, and they had just started a new research initiative called the West Side Fire Initiative. And so there had been the Eagle Creek Fire, I think 2017, that really affected folks outside of Portland and things like that. So we had started learning and compiling all this information about what we knew about fire here on the west side, west of the Cascades, our moist forests here. And that's when the 2020 fires hit. And that really sort of changed my thinking and a lot of thinking for a lot of folks doing the science and the forestry thing here for what I do. And I'm gonna talk a lot about that later on. And then finally, I'm now with OSU, working as a research professor over there and doing some teaching. And so in my free time, I live with my wife. We live outside of town down Peoria Road a little ways, and we have a 2-year-old. We met during COVID. And yeah, Patrick, our son, is sort of what we focus our lives on these days when we're not at work. He loves to ride bikes. We love to ski. We love to get out. We spend a lot of time outside. And I think the one thing Patrick has really opened me up to is birds. He's an avid bird watcher. Not something I've ever been very into, but I'm learning very quickly. And so that's a little bit of a lag here. Yeah, and so let's turn now to fire ecology. And this is a book here, Fire Ecology of the Pacific Northwest. It's from Jim Agee. And Jim Agee has been around. He's retired now, but he really is sort of the godfather of fire ecology here in the Pacific Northwest and has a tremendous amount of information in this book. And it's interesting because it's published in 1993, long before we really saw this huge upticks in fires. And he's really able to sort of figure a lot of things out by looking at the past and thinking about how things work. And so fire ecology is a branch of ecology, and it focuses on the interactions between fire and the environment, which would include living organisms and non-living parts of the ecosystem. Fire ecologists like to look at impacts on ecosystem structure, function, biodiversity, and how fire regimes, this is patterns of fire over time, and how these influence the particular ecosystem. And so I'm not sure how many folks are familiar with fire ecology or our local fire ecology. We're going to talk a little bit about it, but the boreal forest, where this is quite unique. And so that environmental setting is really, really important. And, one of the things we know that fire is, it's been a really important evolutionary process for millennia, longer than that. And we can see that because a lot of the species in our forests and elsewhere are really quite highly adapted to fire. And I have here just a group of pictures to try and demonstrate some of that and some of that thinking. And so this is a picture from the Southern Appalachians. This is mountain laurel. you can burn it really, really hot and it comes back within weeks. So it has a strong resprouting mechanism. This is another picture from the southeast. This is shortleaf pine. It's one of the few conifers that can resprout after being burned, right? A great mechanism of resilience. It's another picture from the southeast. This is wiregrass. Wiregrass is really interesting because it's really adapted to the seasonality of fire. And so wiregrass is sort of like a keystone species. It provides the fine fuels for fires to carry across these savanna ecosystems, but it only flowers after growing season fires early on when it's the lightning season. So it has this really, really neat tie with lightning and sort of its life history strategy. Serotinous cones, maybe these are sort of the flagship of fire adaptations. This is from Table Mountain pine. These cones will stay shut until a fire opens them up and the heat sort of releases the resin. Lodgepole pine is one of our more local serotinous species. Knobcone pine is another one down in California. And this is a shot here of black spruce of the boreal forest. And black spruces actually exhibit serotiny as well. It's not all cones stay closed, but some of them do. And so it's really sort of this bet hedging strategy that when a fire does come through, there will be seeds there to recover. And then another one, this is just a picture of me next to a humongous Douglas fir. And these Douglas fir that lives for hundreds and hundreds of years have incredibly thick bark. And this bark allows them to tolerate really, really high heat. It insulates the growing part, the cambium and things like that. They're also really, really, really tall. And so their canopies are up high. And so these evolutionary sort of adaptations and things like that are really manifest in quite a variety of ways. Stepping a little deeper into fire ecology, it's not rocket science, and this is sort of one of, I think, the founding principles of fire ecology. We call it the fire behavior triangle. And the basics behind this is that there's these sort of three principal components here: fuels, topography, and weather. And it's almost like a chemical reaction where you have three chemicals or ingredients that go and things only work out in a certain way if those are right. If one of those is limiting, it will sort of change the course of fire. And so certainly topography, the template of the landscape, fire tends to burn slower downhill and faster uphill with heat as things pre-warm. Weather, of course, hot, dry, windy conditions. This is really the driving force in this fire weather book. Certainly from the 2020 fires, we know the importance of weather. And then finally, fuels. What's out there to burn, right? Whether there's a lot of dense biomass that's really, really dry versus some sparse biomass that's really going to affect your fire weather. And fuels is really important these days because of this whole fire triangle. It's the one thing that really we as humans can affect, right? And it's somewhat controversial about how we should manage our fuels to mitigate fire. So very, very important things to consider. And then fire regimes, this is maybe a heavy figure, but the way fire ecologists think about fire regimes, this is just a way to characterize how fire interacted or behaved over long time scales and at large spatial scales. And the way that we break this down is first by frequency. So how often does a place receive fire? And so this would be really, really frequent. This might be like our dry ponderosa pine forests. To very, very low frequency, so long fire return intervals between fires, a little bit more like the boreal forest. And then we have this sort of proportion of total area burned in high, where there's a lot of tree mortality versus low. And we can sort of characterize these things into different bins. And so a frequent low severity regime might get fires every 10 to 25 years, and most of the trees survive. Maybe only a couple trees die here and there. And then at the other far end, this infrequent high severity regime would be something like the boreal forest has, where fires are not that frequent, but when they do happen, they're characterized by really, really large patches of dead trees and so on. So this is sort of a brief conceptualization of fire regimes. And I'll probably refer back to that later on. So how do we know anything about these fire regimes aside from looking at what we can today? And so this is a cross section from a colleague of mine, Andrew Marshall. And Andrew spends most of his time going out in the woods with a chainsaw and cutting up old stumps. And he brings them back to the lab and sands them down. And he can precisely date fires back hundreds and hundreds of years, right? So this is a Douglas fir connected near Loon Lake, Oregon, pretty high and cold, but down in the Umpqua National Forest. And since this tree established in 1490, he found 7 fires, the last one being in 1889. So Andrew's able to really recreate these fire histories quite precisely, and it's a really neat sort of time machine to look back and gain some new understanding. Clearly, this tree survived several fires until it was cut down probably in the 1990s. And the way that fires sort of drive historical dynamics, this is probably what most people are familiar with. This would be sort of a low-density ponderosa pine forest on the east of the Cascades where it's dry. And what we had are these frequent low-severity fires every 10 to 25 years or so that would sort of clear out the underbrush and kill some of the trees that had grown up in the meantime since the last fire, and sort of maintain this open structure back and forth. Things would regrow and then we would have these fires. And in these places over in Sisters, right? It's hot and dry every year. They can burn conceivably every year, except they're fuel limited. They don't receive as much precipitation over there, so things grow slower. So there's a fuel limitation. And there's tons of those fire history scars from ponderosa pine. And this is sort of the characteristic story across much of the Western United States, right? Since 1850 or so, with colonization, livestock grazing, then the exclusion of fire starting in the early 1900s, these forests have become denser. So there's more trees, there's more fuel. And those fuels are now more spatially continuous across the landscape. So fires can move into their crowns and move quicker and more rapidly. And this legacy of past land management has really increased the potential for high severity fire. So that's really an East Side phenomenon, and just a little bit about some local fire ecology. And so generally speaking, I think I try and sum it up in just a couple of questions here about what my work and the work of a lot of fire ecologists today focus on. And it's really this sort of our contemporary fires. So the fires that we're reading about now in the news and are potentially happening in our backyards, those happening the same way they might have historically. The second one, of course, is how can we mitigate or adapt to fire effects in these contemporary fires, and then moving forward, how can we do this as communities into the future? These are, to me, sort of the big questions on a fire scientist's plate these days. And we're going to think about a little bit of each of them. And so now moving on to the book. How many folks read it? Yeah, I enjoyed it. It's chock full of details and science, and I'm not a detail guy. So I'm not going to dive in too deep, but what I wanted to do was try and go through each of the 3 sections that the book is split into by John Vaillant. And the first is Origin Stories, Fire, Weather, and Reckoning. And I did, as I was reading it, I underlined things and made notes in the margin that I was going to revisit. And then there's way too many of those to ever sort of condense and put together. And so what I've done is just sort of taken some quotes and some pictures to help sort of jog my memory, and maybe if folks have things to contribute as well, they can do that. And so the first part, this origin story, sets the setting and the location where we are in space in this town, Fort McMurray, Alberta, and it's a city. I mean, I think about 100,000 people, so very different than Corvallis, but similar in size in a way. And you can see it's really quite pretty, right? It's very orderly, new houses, a lot of new growth, some low hills, that beautiful Athabasca River that runs through it. And sort of as far as the eye can see, the boreal forest. And one of the things that really stuck out to me is its remote location. Fort McMurray is up there and out there in what I would call the Great White North. I mean, it is very, very far north. And so up that far north, if a tree burns in the forest and nobody sees it, does anything happen? And in this case, it's very different, right? Because there's this city that's been sort of built by the petroleum industry, right? That's pumped money into this and grown. And it is out there, and it's out there in the boreal forest. It is cold, very cold, permafrost under the ground, tundra in that area, and this boreal forest is just sort of an endless sea of black spruce, balsam poplar, just a couple species, not quite as diverse as it is here. Um, but the interesting thing is this climate that it has, and early in the spring, this time of year, it actually gets quite warm and quite dry, and that's when these fires happen. If you look in the news, there are fires up there now in the boreal forest. And so really kind of a unique setting. And also I think a very unique history in a couple ways. And in some ways it's not so unique, right? It sort of has this history of exploitation and resource extraction. And Vaillant gives a lot of details. It's great, the history of Fort McMurray as a fort, as an outpost back in the day, sort of how it grew and before the tar sands came along, it was beaver pelts and the Hudson Bay Trading Company. So it shares a lot of that with the Western United States. And there's this abundant resource and it's extracted until it's not, and it's gone. And so the other thing up there is this bitumen. And I have a couple quotes here that I'm going to sort of go through. And this bitumen is nothing new. This is a quote about it occurring in Babylon, and people would go to large efforts to collect it. And although the multitude is without number, the yield, as with a rich well, remains inexhaustible, right? So there's this inexhaustible resource of petroleum way, way, way up there in the boreal forest. The problem is that you can't put a well in there and pump it out. It's in this magic sand pile, these bitumen sands, and the science that John Vaillant presents about how they extract that, it's just overwhelmingly energy intensive. It's hard to think how it could even be worth extracting all that oil, but the way oil it is, right? And they have this endless pile of it, and for the last 100 years, the government has been trying to recruit people to go up there and build and take advantage of it, and harvest it, so to speak, and build that economy. And they've done that. It is a massive petroleum economy up there. I want to say, again, I'm not a detail guy, but something like 40% of the oil that we use here in the United States comes from up here. It's a lot, right? And I think one of the things that Vaillant does really, really well in this book, again, I have a bunch of examples underlined in here, but the one that really, really sticks out to me is when he's talking about these pipelines that serve the fossil fuel industry in Alberta, right? So there's 80,000 people up there. They love to burn oil in their trucks and things like that, but most of it's got to head south. And so I think this picture was pretty telling at the extent of those, but also in there's some text that talks about, it gives the mile number. And I forget what that is specifically. It's like, okay, that sounds like a lot. And then he goes into explaining that the pipelines that move that oil to the south would wrap around the Earth's equator 3 times or something like that, right? It's quite remarkable. And to think that there's always oil flowing through those and being used and extracted is quite remarkable. And now nothing will be restrained for them, which they have imagined to do. And this is sort of from the Tower of Babel. And I think in many ways, Vaillant sort of paints this Fort McMurray as a bit of a Tower of Babel, right? Where it's created this huge infrastructure based on this resource-based economy, and then ultimately sort of pays the price of some of the side effects on climate change and things like that. And so the second part, fire weather, this to me was really sort of the meat of the book. And it's just chocked full of people's experiences, these firsthand accounts. And the quote that he opens this one with is, "I balanced between destiny and dread and saw it coming. Clouds bloodshot with red of victory fires. The raw wound of that dawn, igniting and erupting, bearing down like lava on a fleeing population. It's a pretty vivid statement. And I think it's quite reminiscent of the personal recollections that are shared throughout this. And part of those recollections, and one of the things that I think Vaillant focuses on, and this is the quote that he starts with here, the greatest shortcoming of the human race is our inability to understand the exponential function. So who's heard of exponential growth? Yeah, and so we understand it, right? We wish it would happen in our bank accounts or with the stock market, right? It'd be great if this is what it looked like. And so what happens is you have sort of growth at a relatively slow rate, and then all of a sudden there's this threshold or crossover. He uses the term crossover quite a bit, where that growth just really goes bonkers and out of control. And one of the themes early on in this part was this theme of, I guess, complacency, right? And he talks about these black swan events that the people in Fort McMurray had never experienced something like that they were about to. They were experienced with fires and things like that, but it's impossible to know the potential for what's coming if you've never sort of experienced that sort of thing. So there's all these stories about how long it took people to respond, right? How long it took officials to evacuate that city. There's one, I connected with this. There's one professor in a university there, and he's down in his basement office until like 3 o'clock the day they evacuated. Just sort of unaware, right? And if you've never experienced a city burning down, it's a little bit hard to imagine. I think officials, no one wants to say, get out now, because if that fire doesn't happen, I think the quote in the book was, you look like an idiot. And then if it does happen, your town burns down anyway. So it's really, really hard questions for these people in positions. And I think probably people might do things differently now. But without that knowledge ahead of time, it's really, really hard to make those calls. One of the other themes I really picked from this section was this novel fire environment. And so this is a quote from the co-founder of Community Planning and Assistance for Wildfire, so someone who is in the book. And he says, we don't have a forest fire problem, we have a home ignition problem. As soon as you come to that realization, it changes your view on wildfire, right? And it started as a forest fire, right? Moving through the boreal forest, and all of a sudden the city is burning up basically over a day, and these firefighters are confronted with something they have no experience with, right? And a lot talks about, the petroleum-based furniture that we have in our living rooms are basically accelerants, curtains that are made from petroleum, those sorts of things. And so, vinyl siding, all those things. And so in a way, our homes are actually more flammable than they used to be. And he does some comparisons and things like that. The other thing that really struck me was the recollections of the firefighters that were in there doing it. And at some point they had this realization, like, it's not working, what we're doing isn't working. And they start trying different things, which I think is really quite brave. And I think they time it starting to take 3 to 5 minutes for each house to burn. Right? An entire house, 3 to 5 minutes. And so what they do is they figure, well, if we can get out in front 20 minutes, what we're going to do is we're going to start leveling houses and removing the fuels. This is like on the fly fuels treatments in the middle of a major conflagration. So they're knocking houses off their foundations. They're pushing the vehicles and things like that into the basements to try and create fuel breaks. It's mind-blowing to me, but just sort of an account of how powerful those fires were and what that fire environment was. And here's just a backhoe just tearing down houses. And then I think this second part, the meat of it, it's the personal stories. And Vaillant is he's not shy to talk about how he feels about climate change. Right. And the culture in Fort McMurray is one of big trucks and snowmobiles, petroleum burning toys. But I think he goes up there and he makes connections with individuals, and he recognizes how brave these people were to fight these fires. And he gets a lot of personal stories, and it's interesting. I can't think of many of these offhand, but some of them are actually on YouTube. You can go, I think McGrath was the last name of one of them, and this person was, what was the McGrath? You know, he was basically watching his house burn from inside his truck, and he filmed it, and it was ended up on Canadian news. And so there's lots of these stories about people evacuating. I think they evacuated 100,000 people. I mean, just an incredible amount. The total death toll in this fire was 2 people, which is quite remarkable. It was actually in an accident. It was not in the fire. And so you own the fuel, you own the fire. This part is really, I think, in my mind, where he was really able to connect with the people of Fort McMurray and draw from those experiences. And then Reckoning. This is the end of the book. It's a little bit shorter. I gave them fire, but I have no device to free myself from this disaster, right? So this quote here is sort of like you're presenting something with someone and taking responsibility for it as well. And I'm not going to dive too much into the end here. I don't want to do a spoiler alert, but what is remarkable is the deep dive that goes into the history of the research on climate change. So tomorrow came and went, right? He presents this whole history about sort of the discovery of the greenhouse effect and things like that. And it was back in the 1800s, you know, as the Industrial Revolution was going on, scientists were starting to recognize that carbon dioxide has this property where it lets the energy and the heat in, but then it traps part of it. And so people are doing microcosm experiments back then. And then over time in the 30s, as physics is advancing, people are basically doing without computers these back of the envelope estimates of if we release this much CO2, this is how the global temperature is going to change. And they're actually quite accurate. We have far more sophisticated ways to do that now. But what they were projecting that back then isn't that different actually. And the one thing I think Vaillant really, he points a finger at the industry. And there's a lot I didn't know, and this was the thing that really struck me. But I mean, this is the mid 1980s. This is a figure from Exxon, right? And so the petroleum industry itself is actually studying the effects of climate change and CO2 and making these calculations and coming to very, very similar conclusions as other scientists. And this is sort of the basis now where you see these lawsuits against the petroleum industry for climate change, and that they knew what they were doing, right? And this is, I mean, this is it right here. This is from Exxon. It's from 1982. And it shows basically past changes in temperature without CO2, and then how it goes up into the future in terms of uncertainty. And so I think we all know a little bit more about climate change and sort of where that's going. But I think what will be really interesting is what happens in this community of Fort McMurray. I think I read 2 years afterwards, they had reconstructed about 20% of the structures. So people are moving back there. But Vaillant also paints the story of a lot of uncertainty about what's going to happen with the oil industry. And it does, it makes you think. It's like, geez, is this going to happen again? Could this happen again to Fort McMurray? And so with that, we're going to sort of come back to Western Oregon here and start thinking about our own sort of contemporary fires. And I have a video here that Aaron Zuspan, that is a fellow that I work with, he put together. There's some music in it too that's going to come from the computer. I hope this goes well. But just wanted to sort of sit back and think about the magnitude of the changes. This is for the Willamette National Forest, so not too far to the east. And it's a time series that shows all the fires that have popped up since 1985. pretty quiet. Things start lighting up a little bit more around the Willamette, some of the drier places. Two 2017 was big. 2020, wow. 2021, Cedar Creek Fire, 2022. And so there is a remarkable footprint of fire from the last 30 years, really here in our own backyard. And so we're living with it. This to me looks like exponential growth, right? Right? I don't know how much fire there's going to be this summer, but there's going to be some, that's for sure. And so what I'm going to do now is dive back into the science and the science that I do and give you a little bit more perspective on these contemporary fires. And so these are patterns of fire severity from 1985 to 2010. And I have 3 different forest types, 3 different historical fire regimes. Ponderosa pine over in Sisters, our wet western hemlock there in the Willamette National Forest, and then our cold subalpine forests. And the way that I came up with these figures is I use a lot of remote sensing. The Landsat satellite is up in space. It's been there since the mid-80s. Takes pictures of the Earth every 2 weeks, I think, is this particular satellite. And each of the pixels is about the size of a baseball diamond. So it's a pretty good resolution. And we basically get these digital pictures from before and after the fire, difference them. And that difference, that amount of spectral change is really highly correlated with tree mortality. So we then put that into bins, which we refer to as severity. And so you can see Ponderosa pine, a lot of low and moderate severity, but 24% high severity. It's about 5 times more than we think happened historically in those frequent fire forests. So more high severity fire than we would have thought historically. Western hemlock, this is our moist forest, actually only about 20% is high severity during this time period. And then in our subalpine forests where we have sort of this low frequency, high severity regime, fires are common, but when they happen, a lot of trees die. We see more high severity fire. So when you think about fire severity and contemporary fires, it really depends on where you are in the forest type that you're thinking about. And so we have evidence that fires are getting bigger and that these patterns are shifting. And certainly 2020 was a turning point, right? So we have almost as much area burns in 2 days, 350,000 hectares, and in the last 50 years together. It's extraordinary. I can remember I was on a backpacking trip in Northern California, hadn't tuned into the news for 5 days. I decided I wouldn't do that until I got home, and I'm driving north through Cottage Grove and into the valley, and all of a sudden I hit the smoke. And it was like, this is happening. This is going to happen in my lifetime, and it's happening now. These fires were far more larger and more severe than recent fires, and it was really this unique weather and late season drought. I think if you look at 2020 as a whole summer or a whole year, it wasn't necessarily that hot and dry, but that 2 weeks before those fires in late August, it got really, really hot and dry fast. And of course, there was the wind event. And I think it's a generational event. It's actually characteristic of the historical fire regimes here on the west side. And so we put together some work. I mentioned this West Side Fire Initiative with the Forest Service. We've been collecting all these historical fire perimeters on the west side. And when we overlaid those with the footprint of the 2020 fires, we saw some remarkable things. And so here in red, these are the 2020 fires, the big 5 there. The 1902 Columbia burn up in Southwest Washington, also here outside of Portland in Oregon, huge. Of the magnitude of these fires, the Tillamook fire back in 1930 sometime. These are Coast Range fires that have been reconstructed in the 1850s. Big high severity fires. And then these hash marks are places that in the early 1900s, they would go out on horseback and go up mountainsides and map forest conditions. And these were places that were marked as recently burned with no standing timber, basically all high severity fires. And you can see how much of that there is in the early 1900s across the west side. And so we have this historic precedent for these fires here in the West Side, and not only for the size and the seasonality, but also some of the places that we see mapped in 1902 are places that burned in 2020. And this to me is remarkably telling. This is looking west from Kinney Ridge, over here, basically the Detroit area. And so this is looking down that North Santiam River from a lookout in 1937. It looks fairly similar today, except there's a lake at the bottom of it, right? And so these fires have historical precedence, and they've been around. And so this is an old slide that I usually present, and there's a sort of a specific recipe that we're trying to learn more about. But first we need an ignition for one of these big fires, very, very dry conditions, and an east wind event. But I think what we're learning is that these very, very dry drought conditions, they come with this east wind event. So those really, really dry things out as the wind comes over the east side and dries it out. And so we know that this is what drove the Tillamook fire. This is one of the iconic West Side fires of the 20th century. And so these dry east wind events, like what we had in 2020, this is a figure that I put together from some data that a fellow named Owen Kramer had in one of his papers. And what Kramer did was he went out to the Portland airport and he used weather balloon data. They send weather balloons up every day that record conditions, wind speed, relative humidity, wind direction, and then they take it down and they log it. And what he did was came up with this threshold for, basically a wind speed greater than 12 miles an hour, I think that is, and a low relative humidity. And when you look at the frequency of these dry east wind events, there's a very specific window of vulnerability here in our region. And it starts in mid-August and it goes basically until those first rains. And so basically we never have these east wind events, and then all of a sudden, we have a very specific seasonality to them. And then these are dates of just some of the big 20th century fires. And it's incredible really how close they correspond with that window. I mean, that 1902 fire, September 11th, is just a couple days away from the anniversary of the 2020 fire, right? And so from year to year, it's hard to predict what's gonna happen. But we know around Labor Day, this is where these winds really, really start operating. And we can take this and use sort of reconstructed climate data, do a little magic, and point to places in our region where these are more likely to occur and more frequent. And so certainly the Columbia River Gorge is a hot spot for these, right? That's why all the windsurfers are up there. The Brookings effect, we see it down here. Some of these higher elevation areas. And so we actually know where these might be even more common, right? And I think this is a really important map for folks to understand. They're very, very infrequent out here by the coast, but they happen, right? That's Tillamook burns. And so the Tillamook is really an iconic fire for fire ecologists, and I think for folks here. Anybody know anybody that was around during the Tillamook burn or ever heard any stories? Yeah, these are a little bit, yeah, they're generational events, right? It's part of lore and history, really. But this is something I dug up from a grad student at OSU back in 2001, and it has sort of the map of fire spread of the Tillamook burn. And you can see how it starts real slowly here in mid-August. Relative humidities were up around 40 or 50%. Wind speeds weren't that high. And then boom, on August 25th and 26th, one of those east wind events, and 3/4 of the total area that burns in a couple days, just like the 2020 fires. Another interesting fact about the Tillamook burn and that Yakult burn up there in Southwest Washington was that they reburned in the decades following those fires, right? And so here's the Tillamook burn. I think they call this the 6-year curse or something like that. 1939, 1940, 45, 51, 56. The Yakult burn, sort of the same size, I think had about 15 reburns in the following decade. And so these moist old growth forests, they might actually be hard to burn, but you have one of these really, really large fires and it completely changes the fire environment. if you remember back to the fire triangle, the fuels are now fine fuels. They're herbaceous things that are growing back, grasses, forbs, plants, young tree regeneration, and it dries out. This is an old study. Bonita Neeland was a professor at the University of Oregon back in the 50s. I love digging the old stuff up. They had a lot of it figured out. But she found that in the Tillamook burn, it was 10 degrees hotter in recently burned areas than in unburned areas, right? And so that's the magnitude of what we're expecting at the end of the century with climate change, right? And so those 2020 fires, it's like they got fast forwarded in a climate sense 80 years. So some interesting dynamics to think about there. And then back to the boreal forest. And maybe this is one thing that maybe Vaillant didn't quite hit on, but it's that question of, are these fires that we're having today out of historic conditions? Are they something new? And this is a study from somebody up in Canada. Chavadres is the last name, and it's just a map of all the modern fires since 1980. There's a lot of fire going on in the boreal forest, a cold place, but lots and lots of fire. And then these are fire history studies, like I showed you before. And what they found, I'm going to show you a figure from this Wood Buffalo site. This is fairly close to Fort McMurray, and you can just sort of look at this y-axis as in more fire, less fire, but you can see that it fluctuates through time, right? This is the Little Ice Age, a very, very cold period back between, say, the 1600s and 1850s. And so actually today, looks like maybe we don't have as much fire as there used to be in the boreal forest, right? It's hard to imagine. They certainly weren't people putting them out with helicopters and things like that back then. So it just sort of demonstrates the tremendous potential for our systems to burn. And there's this term that's been coming up in the science circles, a fire deficit. And what we're realizing is that as much fire as we have on the east side now, we had a lot more historically. We're not even close to how much fire. The Fremont Wainema, where the bootleg fire burned, we did some work and found 80,000 acre fires every decade down there. A lot of fire. Even here on the west side, we have a fire deficit. We're climbing out of it very quickly. But this is sort of where fire is at currently compared to what these studies all across the boreal forest have put together. It's hard to imagine how much fire there was historically in many places. And so just to wrap it up, I'm going to talk a little bit about living with climate change and wildfires. And I don't think any of this is new, right? The temperature's been warming for the last century, and it's projected to get even warmer. And I talked about those back of the envelope calculations from the early 1900s. These days, scientists are using very complex models, these global circulation models. And what they do is they have these different RCPs that's called here. And these are based on essentially how we as humans change our behaviors. And so this worst case scenario, RC 8.5, a 10-degree Fahrenheit change by the end of the century is just sort of business as usual, right? And then these other ones, this is sort of we have some mitigation. If we change the amount of oil that we burn and the CO2 that we put out there, we can potentially alter that scenario. And so there's a lot of consistency that things are going to get warmer. We know that it's already happening. In terms of precipitation, there's a lot of variability, right? It's not quite as certain. Some things say, for the most part, that we're actually going to get a little bit wetter here in the Pacific Northwest. But when you look at that seasonally, most of that comes in the winter when it's warmer, more rain on snow, and summers actually get drier. So decreases, we don't get a lot of precipitation here in the summer. The projections for that are for decreases in the summer and fall. And this is our fire season. And so we've already seen sort of this pattern of area burn. This is across all of Oregon and Washington. It's very highly correlated with climatic water deficit, which is basically the amount of water that a plant would need to sustain itself minus what there is for precipitation. Okay, so what is the plant available water? And when we look across the West, we see these huge increases in climatic water deficit, really, really large increases in climatic water deficit. And so based on that assumption that there's going to be more climatic water deficit in the future and that relationship with climatic water deficit and area burned now, we can jump to the conclusion that there's going to be more area burned in the future, right? And so that would be what I would call a statistical approach to talking about how much fire are we going to have in the future. But we also have some pretty nifty computer simulation models and things like that that start incorporating weather and climate over time. And this is some work, a colleague, Alex Dye, who now works at the Oregon Department of Forestry doing a lot of this modeling, uses this FSIM model, where we basically take past fire perimeters for the last 30 years and look at the weather and how things behaved and then simulate them into the future, but with different climate conditions. And so these are some of the projections for the future. And right here, this is a burn probability. So places that are red have higher probabilities of burning and those that are blue have lower probabilities. And then this is the change in the future. And it's interesting to think that, you know, the Coast Range, there's not as much change there. There's not that much fire. But places like the Willamette National Forest, I think that's an increase of about 110%. And the one thing that when we did this work that we didn't really have a good key on was we made the 2020 fires unburnable. So these are places that couldn't burn, but we know now that these places are probably actually more flammable, right? And so the model doesn't account for that, and it's probably an underestimate. So quite a bit more fire into the future across the region. And so we talk a lot about adaptation, and from an ecological side, there's a lot of options out there. There's a lot of discussion, and I've sort of boiled them down into 4 really short, brief ones for everyone here. And so these are some of the pre-fire management options: stand level fuel reductions, right? And so we know that these can work in places where fire was more frequent historically. High severity regimes, moist places like the west side, we don't know that much about. Certainly fuels treatments wouldn't have helped Fort McMurray, right, under those weather conditions. And so the thinking is that under moderate weather conditions, fuels treatments might be able to help in some of these places, but in 2020 fire conditions, there's not much that you can do. Certainly limiting human ignitions, especially here on the west side during that window of vulnerability that we know those east winds are very, very common. Aggressive wildfire detection. Got to know when they start and put them out. And then finally, developing post-fire response strategies. So what do we do in the aftermath? And we're learning a lot more about that now because we're able to study it because there have been fires. But then there's also sort of the social adaptation side. How do we as people, how can we adapt? What are the things that we can do? And this is in particular context of the 2020 fires, anticipating black swans. And so black swans, again, are that sort of thing outside of your realm of reality that you don't think can exist because your experiences are so limited, like the 2020 fires in many cases. And so thinking about adaptation to fire socially might be more appropriately thought of in terms of like an earthquake or a tsunami. Right, these low probability but really, really, really high consequence events. And so I think investments in evacuation, right? They were able to get a lot of people out of Fort McMurray. It was pretty incredible. But we have a lot of vulnerability to that and a lot of variability across the region here. This again is some more of Alex Dye's work, and basically the red dots are places where evacuation is really, really limited by roads, right? And if you remember that vulnerability to wind map that I showed, places up here, places along the crest. And so in terms of planning for the future, knowing how to get out can be really, really important, and knowing how to do it fast, knowing how to notify people. And then finally, you know, structural hardening, right? If you think about Vaillant and talking about all the vinyl siding and things like that, we can potentially make a difference in our own homes by what we're building with and how we manage the things around them. And that might not make a difference in a Fort McMurray fire or a 2020 fire event happens, but it could make a big difference in other situations under more moderate conditions. So I always, it's like, if the boat's going down, I'm gonna bail it out either way. So, yeah, with that, I'd be happy to, take any questions or do a little discussion about the book or fire ecology or.
No,
Yeah, I think Vaillant, he uses this word virulescence at the end and has some pictures of like a completely nuked house with some tulips coming up. And so I always try and end my talks with something a little bit uplifting. Yeah,
fire in California, when was that?
I think that was 2018.
Yeah.
Yeah, and that was, at least to me, that was one of those first big wind-driven fires. I was in Humboldt at that time, and I remember it. It was a Sunday, and it was a day you didn't want to go outside because the wind was so harsh and so strong. And usually in Humboldt, the wind comes off the ocean, but it was going the other way. And so I don't know that the Paradise Fire was necessarily that big, but it sure was destructive, right? I think that's one of the lessons.
Way out in the town, yeah. How would the, the one up north in Canada compare? It was a hotter fire?
Yeah, so the climate was extraordinarily warm that spring. Yeah, so that was really, really hot. And I don't, it wasn't necessarily an east wind event up there as much as it was the heat of the fire itself generating weather. And just the fact that when those winds are strong and there's that much fuel, it moves pretty quick. And once a fire that size gets moving.
So you mentioned the east wind. Is that just something that happens that time of year always or?
Yeah, yeah. And so the east, I'm not a meteorologist, but essentially my understanding of what happens is that we get this cold, high pressure from the Arctic that comes down from the east side of the Cascades, and it creates sort of this pressure differential. And all that cold, dry air, it starts cold, comes pouring over the Cascades, and as it descends, it warms and gets faster, and that's where those expectations.
It happens every year.
It does, yeah. I mean, we have the Santa Ana winds. Those are sort of the same. Phone winds is sort of a generalized name. Anybody hear about the fires in Gatlinburg, Tennessee back in 2016? Yeah, they call them mountain waves down there when you get these pressure differentials and these strong drying winds.
Just a comment. My husband and I know John very well. He's our son-in-law. And something that he just said not that long ago was that he did go back to Fort McMurray recently.
Yeah.
And it is almost, you said 20%. It's totally rebuilt now. And the interesting thing is they still have the plastic siding and the composite roofs that burn. So they rebuilt the city. Exactly. It's kind of like nobody learned anything.
Yeah, it's really interesting. I was sort of talking with my wife over breakfast today, and I was talking about, well, I'm not going to say too much about the end of the book. I don't quite know how they've recovered. And she said, well, did you look on a map or look into it at all? And I chose not to. It's like, I'm not going to go, but I know that. Yeah, I don't know what to say. It's a tough lesson learned, apparently.
Maybe in New Orleans, but from different reasons.
Yeah, yeah, and Katrina was,
Could you repeat her comment?
Hurricane Katrina.
Once
Yeah.
for different reasons, they rebuild the same way.
Yeah, there is it's humans, right? And it's easy for us. It's like, geez, maybe that's somebody's dream home up there. They really, really love that place, And, yeah, we live out in the valley. I think we're pretty safe from wildfires. Grateful for that.
Well, I don't know that it's that relevant to this, but there are, I think, some historical events where we learned or apparently we did something different. I think there was some major changes in building construction standards, for example, in the city of Chicago after the 1871 fire, which was, burned down a third of the city. but there were a lot of things, and there were a lot of things before that fire that were not allowed afterwards.
Yeah, earthquakes.
Taking construction materials and also placement of buildings and everything.
Yeah, there's a work at OSU. I think they have, I'm not remembering the names, but folks that are studying that sort of thing, and they have a big open space where they can burn things. You know, and so, yeah, I don't know if they were just trying to build this quickly. The price of real estate in Fort McMurray is pretty high. The value of gas is pretty high apparently too, so.
The second last slide, if you could go back there for just a moment. What is it? What causes, is there a common it's actually, I'm sorry, I was considering the last one, where all the dots are.
Oh, yeah.
What is it about the black spaces? Is that urban? Is that, I mean, I'm trying to figure out what, because that's the highest.
The dark red places?
I think the black is the highest vulnerability, right?
They don't have those mapped. These are, and so the black are urban areas and the dots are just places where they studied it. Yeah, and the focus was on rural,
Okay. So
rural areas more so.
Mater between the darkest dots that have been mapped. What is it?
Yeah, and so I think those are places that have potentially high fire risk and then poor infrastructure.
There is it the, is the topography, is it the,
Yeah, fuels and weather, essentially. Yeah, yep. And then topography, of course, limits evacuation routes, right? There's only a couple ways out of Detroit, that's for sure.
I see.
Yeah. Yeah, there's really, you know, I started this as a botanist, you know, that was ecological science is my interest, but social science is a really, really important part of the fire science world today, and sort of understanding human responses and behaviors is pretty important. Well, thanks so much for coming out. I hope you have a smoke-free summer.
Hearing observation.
I'm sure.
My hearings generally go to the third, about the whole.